A very good morning to all of you and welcome to today's session. Today we'll be talking and discussing about unsupervised learning. So we'll be primarily discussing clustering today. So let me share my screen and then we'll go on from there. So I hope my screen is visible to everyone and I'm also audible.
Yes, yes.
Yeah, thanks. Okay. So this is the outline. So, if you all recollect, in one of the first few lectures, I had discussed very briefly about what is clustering. So, today we'll be taking it in much more details. First of all, clustering is also said to be unsupervised learning because in this case, we don't have any information about the data. So, in supervised learning, if you recollect, which is also uh, used for classification. The term is used for classification also. So in that particular case, we are given the class labels and we have to build a model so that we can classify an incoming unseen data point. In case of unsupervised learning, however, we do not have any class labels with us. All we have is the data and we use this data for forming groups. Okay, and these groups can later be used to identify some relevant class labels. That is how it can help. So clustering is nothing but grouping of data objects or data elements. And to group the data elements, they have to be similar in some way, right? So there has to be a notion of similarity that needs to be utilized. Okay. And so it's very important to be able to identify the correct notion of similarity because the whole of the clustering process is actually dependent on this notion of similarity. And if we go wrong in choosing how we are going to decide which points are similar, then our entire groups will be wrong and the cluster form will be incorrect and our further analysis will be meaningless. So now, so this is just going to help us have a small visual explanation of what clustering looks like. Let us imagine a three-dimensional data space, as you can see here. So in the data space, you can see here that there are natural groupings in the data. So what are these natural groupings? Just a second. So you can see here there are natural groupings in the data. These are the natural groups that are there in the data. Obviously, we are able to identify this because of the visualization that we are doing. Otherwise, no computer system has eyes and cannot visualize this. This is just for shown for explanation that the data points may naturally be organized in some, in some way where if this is the 3D data space that we are talking about, right, like this, then the entire data space may not be full of points, right? Certain regions may be packed with points, certain other regions may be sparsely filled and all that. And the objective of clustering analysis is to find out or identify those crowded regions or groups of data points that are available. And to do that, we are going to use some notion of similarity. And while doing so, what we have to do is that the distance within the cluster that is said to be intra-cluster distance need to be minimized, whereas the distance across the clusters need to be maximized so that the clusters are very dissimilar with respect to each other. And so the inter-cluster distances need to be maximized, whereas intra-cluster distances need to be minimized. So now, if we look at these set of points, how many clusters do you see? Maybe you can respond over chat. How many clusters do you see? 6 clusters. Another answer with 6. 2. I could see 2 answers so far, 6 and 2. I could see someone say 8. 6, 2 and 8. 6, 5. So the answers so far are 6, 2, 8 and 5. Okay. Okay. So let's see. 2 clusters. Good enough. 6 clusters. 4 clusters. I think someone said 5. So I could not understand how 5, but probably uh, 5 is a little difficult to visualize. Anyhow, 5 and 8, I could not understand how they came. But anyhow, so now the question is which answer is correct, whether it is 2 or is it 6 or is it 4 or is it 5 or is it 8? So the point that I wanted to bring out is that the notion of clustering is very, very fuzzy. It's very ambiguous. And we really cannot say whether the data points have 2 clusters or, 6 is correct or 4 is correct or what is correct. Because it purely depends on the data, on how we want to cluster, etc., etc. So you can see here that it's really a very non-trivial task to perform clustering because there is no clear-cut answer to the question that this is correct way of clustering and this is incorrect. However, we'll try to identify how we can form clusters which are somewhat or almost correct. So presently, all the answers like 2, 6, 4 are all correct actually. Because it depends on how we want to cluster. Okay. So now, when we do clustering, as I already told you that we are going to use a notion of similarity and we are going to cluster the points based on their similarity. Though I had taken this up earlier, I've just put some of the slides back again as a quick recap for those who do not remember. So, similarity can be measured with the help of a lot of metrics, right? And proximity, similarity will be used synonymously in this course. And dissimilarity is nothing but reverse of similarity, right? So, this is how we are going to use. Okay, so I had done some annotation. However, please let me choose the eraser and see if I can. So actually, I had done this earlier to save time. So anyway, please look at this expression, which is Euclidean distance, which is just shown here for your convenience again. And this is the root of the square of distances. So if you have 2 data points like, P and Q, then the Euclidean distance will measure the the dissimilarity between the different attributes, square it, add the values for all the attributes and then root it. This is what is the Euclidean distance. And if we look at, let's say, uh, uh, the two data points that we are comparing. So here, let us say we are looking at Q and C. I told you distance about P and Q. So this could be the distance between P and Q, where P could be this blue curve and Q could be the red curve. And we are looking at sample by sample difference between each of these, squaring these differences, then adding them, and then taking the square root. This is what we are doing in Euclidean distance. And a generalization of the Euclidean distance is the Minkowski distance, where instead of the root, we are actually raising it to the difference to the rth power and then taking the uh, rth root, right? And after summing all the distances. So when r is equal to 2, then what you get is the uh, Euclidean distance. Okay. So now we'll return back to what we were discussing. So if we look at these points, um probably these characters may be reminding you of something. I am sure uh, you all remember these characters are nothing but the Simpsons family. Now the question is what could be the natural groupings that could be identified from this data? So there can be so many ways of identifying groupings in the data. For example, male versus female. So that could be one way. Or there could be another way where we are looking at the direct Simpsons family and where we are looking at the extended family, maybe the school employees and all that. So, and there can be other ways also, maybe based on the height, maybe based on the relationship and so on and so forth. So, given a set of points, clustering is really very subjective. And as I said, and it actually depends on what we want to do. For example, clustering on the basis of male versus female and clustering on the basis of the Simpsons family and extended family, both are correct. But they may not be correct in a given context. Maybe in a context where we want to identify what are the, how many people, how many of the family members are males versus females, then doing a clustering on the basis of Simpson's family and extended family may not be correct. So clustering is really very subjective. And it purely depends on how we want to do it, what we want to do with the data. There can be many ways of clustering the same given set of data. Just I'll just do a stop share right now. Uh, Please allow me a minute. Uh, just give me a second. Yeah, sorry for that. So I'm just sharing the screen again. Okay. I don't know what's happening actually. Uh, Once again, please allow me. So I had actually, give me a minute. Okay. I hope it should be okay now. Yeah, fine. Okay. So now the first and foremost thing that we want to, that we should know about any particular clustering method is for us to be able to decide. So we are, remember, we are grouping the data, or we are actually not exactly grouping the data. We are trying to identify the natural groups from the given data. We are not forming artificial groups from the data. So the purpose of a good clustering method is not to forcefully form clusters. Rather, it should be able to identify the hidden patterns that are available in the data. So this is what a good clustering method should do. So we are not forming clusters just for the sake of forming them. Rather, we are forming clusters because we want to identify what are the groups that are naturally present in the data. So this is the first and the foremost requirement of any clustering method. And as we go along, you will realize that though it is very easy for us as humans to think about clustering, to visualize it mentally sometimes, and understand clustering. However, for computers, it is really a very challenging task to be able to identify the clusters that are available in the given data and to cluster them correctly. In fact, none of the algorithms which are existing till date are able to identify the absolute correct clusters that are given the data. To some extent, clustering can be done correctly, but not to a very high extent. So, so now, as I already discussed, that we want to identify the groups that are available in the data. So, what do you think should be some important properties or requirements that a clustering method should satisfy according to you? Maybe you can respond over the chat. What do you think? Let's say that if you were to perform clustering, then what do you think you will expect that your clustering algorithm will be able to satisfy, or what kind of uh, requirements you think you should have in any clustering the method that you're going to follow? So I already told you the first property. So more similarity, based on problem statement, distance from mean of population, geographical data. So we may not have geographical data all the time. Similarity between characteristic in the data set. Okay. Identify how data points are related. Okay. So more similarity to form groups or clusters. So first thing I want to say is that our clustering method is not going to help us identify how to cluster. So the notion or the measure to be used needs to be chosen by us. right? The algorithm cannot choose a clustering measure to be used by us. That needs to be done, that choice needs to be done by us, but it should be done in such a way that we are able to identify the correct clusters. So, the first property that I already told you that any good clustering method should satisfy is that it should identify the natural groupings from the given data. So it should identify natural groupings from the given data. So this is the first requirement of any clustering. It should not form artificial clusters, right? It should be able to identify the natural groupings from the data. Say for example, uh, so I think Ashish, you have a question, what is data and what we want to achieve. So let's say that I have a 2D data space. The data is having two attributes, X and Y.
No, we will look at this. What do we want to achieve on the
Okay,
basis of
okay,
that? We will look
okay,
at. So we'll look for those traits. So that's what I meant.
okay, I got it. So let's say that, you know, these are the given set of points that we have. Say, for example, in the 2D space. So our method should be able to identify these natural groupings from the data, right? It should not happen that there is one cluster which is like this and maybe another cluster is like this. It should not happen like this, right? It should be able to identify the correct uh, groupings that is available in the data. Then other properties. Uh, so another important property that any clustering method should have is it should be able to handle noise or outliers, right? And it should not get impacted or disturbed when noise is there in the data. Of course, if there's too much noise, then that can be a problem and we need to treat the data. But if there is some amount of noise, then the clustering method should be able to handle that. Then our clustering method should be able to deal with different types of attributes, right? There could be numeric, there could be categorical, there could be, so many different types of data sets, and our method should be able to deal with it. Then, if our data is not static, that is, it is coming in continuously, then our clustering method should be able to handle dynamic data. Of course, most of the clustering methods are not able to handle dynamic data, but what if our data is just coming in? There are sensors which are reading the data, or there is a stock price that is, new stock price coming in every day. Then our data is never complete, right? It is getting generated over time. And our algorithm should be able to handle this. Okay, I could see clusters should be explainable. So clusters should be interpretable and explainable. That is correct. Then there are so many other properties that are, clustering method should satisfy. I'm not going to write each one of them. Then it should be able to identify clusters of different shapes and so on and so forth. So let's go ahead and see some of these different aspects. So these are some of the requirements that we already discussed. First of all, our method should be such that it should be able to identify clusters of arbitrary shape. I will discuss more about it as we go along. Okay. Then should be able to handle uh, should be able to handle noise and outliers. It should be able to handle dynamic data. It should be able to handle different types of attributes. Then it should not require some domain knowledge, and it should not have some hyperparameters that should be fed into the algorithm. It should not be sensitive to the order in which inputs are provided. Then if some user specified constraints can be incorporated, that can be good. It should have interpretability and usability or explainability. And the method should be scalable. That is, if the amount of data increases, the method should still give the same performance and it should not fail just because the volume of the data increased. So this is not an exhaustive list. These are some of the important properties that any clustering algorithm should satisfy. However, as I already mentioned, there are no algorithms that are going to satisfy all of these properties. So the algorithms that exist as of today will satisfy some few of these, not all. I'm saying only few and not many. So there aren't algorithms that satisfy many of these also. There are only algorithms that satisfy few of these. Okay. So before we go into clustering, we are going to discuss how the similarity is represented. So we have two data structures for that. One is data matrix and one is the dissimilarity matrix. So we will discuss what is a data matrix and what is dissimilarity matrix. So in a data matrix, we have the data organized in a n cross p fashion, where n are the number of data items and p are the number of attributes. So how can we look at, let's say we have data element 1, data element 2, till data element n, and then we have data element 1, data element 2, sorry. So these are attribute 1, attribute 2, attribute. Let's say we are having p number of attributes, so attribute p. Okay. So each data element is represented as a row in this matrix, and the attributes value, corresponding value, will be the value of this particular row. This is called a n cross p matrix, and its name is data matrix. So sometimes we try to represent the data in this form, and then we are going to use this matrix to find out similarity and all that stuff. A more common way of representing the data is using dissimilarity matrix. Now, what is a dissimilarity matrix? It's a n cross n matrix. Here we are going to have data element 1, data element 2 till data element n, and data element 1, data element 2, like that till data element n. So it's a n cross n matrix where n is the number of data items or data elements that we have. Okay. And the entries inside this matrix is nothing but the distance. So I already told you, for example, we have the Euclidean distance, which is like distance if we talk about data element, or I can simply write P and Q. So it will be the square root of summation of Pi minus Qi square. I is equal to 1 to, let's say, let's say we are having, if we are having a number of attributes, then a. So this is the distance. So we populate this with this distance value, right? This distance. So here this will be the distance between data element 1 versus 1. So with respect to itself, the distance will be 0. Similarly, element 2 to element 2 will be 0, and so on and so forth. This will be 0. So the diagonal of the matrix will be 0, because the distance of data element with respect to itself will be 0. However, the other values will be non-zero. For example, this will represent the distance between data element 2 and data element 1. Similarly, other cells you can populate. I'm not writing it for because it will become cluttered. And any one half of the diagonal is going to be symmetric to the other half. So you can think of populating any one of them, either this, or you can think of populating this, and that will be sufficient. Okay. So the more popular one is this n cross n matrix, which is also called dissimilarity matrix. You can see here, if this is the first row and this is the second row, so this element represents uh, the distance between the second ith row and the jth column. So it is distance between 2 comma 1, like that. Okay. So these are the data structures that we'll be using. Now here I've just put the difference of classification versus clustering because both involve grouping. So as already mentioned, classification is a supervised learning method, and clustering is an unsupervised learning method. So in supervised learning, that is in classification, class labels are given, whereas in clustering, class labels are not given, and we form the groups. They can help to identify, the groups in itself can help to identify the class labels. Okay. So I think I'll stop here and take any questions. If there are questions, you can ask me now, and then we can proceed further.
Shall I go ahead?
Yeah, please.
Yeah. So, I mean, before this, we learned about data matrix and dissimilarity matrix, right? So we would be choosing between these two, and we'd have to specify in the model when we choose, is it?
So you may or may not require. I've told you because usually most of the models will be using the the dissimilarity matrix only. So most of the
Okay.
models will be using this only. However, you should know that there are two ways to represent the data. Okay.
All right. Okay.
Yeah.
Okay.
And the pre-coded functions,
Mhm.
they already have inbuilt methods, to build the dissimilarity or data matrix, whatever they are using. However, if you code on your own, you'll need to specify.
Okay. But in generally, most of the cases, we'll have dissimilarity matrices.
Yes, that's correct.
Thank you.
Yeah. Any other questions, anyone? Okay. Since there are no other questions, I'll proceed and maybe we can return back if required. So there are a lot of approaches to perform clustering. So I will be primarily discussing partitioning. There are other approaches like hierarchical approach, density-based approach and all, which I will just mention for the sake of your background. However, the most popular is partitioning, and I'll be discussing in detail about partitioning only. So what is partitioning? So in partitioning, as the name suggests, we are going to create partitions or subsets from the given data. And to form the partitions, we are going to choose an objective function, which will either maximize or minimize. Usually it is the error, and that is why it is minimized. And some of the typical methods that belong to this category, which is a very, very popular clustering approach, is k-means. Now, in partitioning, when we divide the given data into partitions or sets, I mean subsets, we have to do it in such a way that each and every subset is disjoint from any other subset. Okay. So this means that there are, in partitioning, all the subsets are different. They are separate from each other, and there is no overlap, or there is no intersection. And in this case, k number of partitions are formed where k will be much, much less than n. Because if k is equal to n, then we are forming as many partitions as the total number of points, where n is the total number of data points given to us. So if we form clusters which are equal to n, then we are not doing any clustering at all, right? So therefore, we have to form clusters, and the number of clusters that need to be formed will have to be much less than n. In case of partitioning, we need to specify the number of clusters in advance. This is called this is the k that we are talking about, and uh, each and every in this particular case in partitioning, each and every data point will belong exactly to one group. Why I'm saying exactly? And it is not going to belong, I mean, it is each and every data point is going to belong exactly to one group, neither less nor more. Now, what do you mean by neither less nor more? Less means that there cannot be a case in partitioning where we have a data point, but it is not assigned to any cluster. Or in other words, each and every point needs to be assigned to one group. Therefore, each data point will belong to exactly one group, not less. So it cannot belong to any other, I mean, it cannot be just left without being accommodated in any group. And the other thing I said is not more, because each and every point will be assigned only to one group. Because I already told you, in this case, we cannot have intersecting or overlapping clusters. Therefore, each and every data point will belong only to one particular group. So it's not, there cannot be a case where a data point can be assigned to two groups. Therefore, hence we say that each and every data element in partitioning approach for clustering will be belonging to exactly one group, neither less nor more. Okay. Also, we cannot have a cluster which is an empty cluster. Each cluster will have some points because each point is assigned a cluster. Therefore, each and every cluster or group will have some points, some number of points to it. And of course, it is iterative in nature, which we'll discuss as we go along. Now, as I already told you that in partitioning, we need to pre-decide the number of clusters K that need to be formed. But so how can we decide that? If we have some prior information that can help us to identify the number of clusters to be formed. Otherwise, we have to decide how many clusters we need to form. So then, let's say that, we have these given set of points. As you can see here, there are two natural groups in the data, one shown in the blue circles, another shown in the red hashed squares. And if we need to decide, then what we will require to do is that, let's say, if K is representing the number of clusters, then we draw a graph of K versus the objective function, which could be the error. Mostly it is the sum of squared errors, right? And we keep varying the value of K, that is the number of clusters, and finding out this value. Say, for example, when we had K equal to 1, the objective function was coming out to be having some value, let's say 873. And in this case, all the points are assigned to one single cluster. Therefore, we have one cluster, all of it is shown in this green color. So this is the first case. Now, let's assume they are belonging to two clusters, and then again we identify what the value of the objective function. And we go on doing that as, we keep on increasing the value of K and see what is happening to the objective function. And then let's say if we have K equal to 3, then what we are having is 133.6 and so on and so forth. So in this particular case, you can see that one of the clusters is getting split from here. So finally, what we will do is we'll draw a graph of K versus the objective function, which could be the sum of squared error, or it could be something else also. And here when we vary the value of k, we will see how much of error is coming in, and like that. And then we'll try to identify a point on this particular graph beyond which the value of the objective function substantially doesn't change. So that value could either be 2 or it could be 3. In this case, the value of 2 is correct because this is giving us the exact knee of the curve. We call it knee. What is knee? Knee is the point beyond which the value of the objective function more or less plateaus out. So you can see here, after that, the value of the objective function is more or less similar only. So we identify the value of k where there is a knee and take that value. In this case, k is equal to 2. So this is how we identify the number of clusters to be formed when we are talking about k-means clustering. Okay. Now, how do we actually start out? Say, for example, initially, if all these points here and here together are showing a distribution of some given data points, then initially we just randomly assign points to some cluster. If k is equal to 2 and the clusters that we are having are C1, C2, I just randomly assigned some point to some cluster, say C1, another ones to C2. This is just random. Then again C1, C2, like that. And then after assigning, what we do is we find out the means. So all the points in cluster C1 will be used to find out the mean for cluster C1, and all the points in C2 will be used to identify the means for C2, and then these means will be used for further iterations, which I'll explain as we go along. Now, before we go into more details, I would like to point out the name of k-means. So, k-means, the name itself is indicative of how this clustering is done. K is a value which indicates the number of clusters, and it's an input to the process. Okay. And means identifies the average of the attribute values of all points in a given cluster. Okay. Hence, the name is k-means. K is the number of cluster. Means identifies that we are going to use the notion of average or mean value. And how we are going to use it, I'll just show you. So here I already told you, we have identified the mean of C1 as 2.2 and something and 10.1. And then you can see there is a visualization. So these are the points. These are all the points that have been assigned. So these are the cluster center for cluster C1 and C2. And accordingly, the points are assigned, okay, to cluster and C1 and C2. So then let's have a look in more detail. So we have another set of points. All of them are being shown in the green color, okay. And let's say we are given the value of k equal to 3 right from the beginning. Or in other words, we have to form 3 clusters. So the first step is that we have to randomly assign all the points. We have to randomly choose 3 cluster centers. Okay. So we have to randomly choose 3 cluster centers, which are also called centroids. And then randomly assign the points to these cluster centers. Okay. So we are going to exactly do that. So we have now assumed 3 cluster center as K1, K2, and K3 in this data space. Okay. And then what we are going to do is now, assuming the initial selection is done for the cluster center. Now, let's assume we are having these 3 cluster centers, which are randomly assigned. We are going to now, so these are the first uh, selection. So here what we are doing is we are trying to identify, after identifying three random cluster centers, the closeness of each and every point with respect to each and every cluster center. Right? Say for example, this point is closest to cluster K2, so it will be assigned to K2. If we look at the distance of, let's say, some other point, let's say if we look at this point and we see how far it is from all of these, then accordingly we'll assign this point to cluster K1 like that. So we look at the distance of the points and assign the points to the respective cluster center, where respective cluster center means the cluster center which is closest to that point. And on the basis of these, you are seeing this three, since K is equal to 3, you are seeing these three cluster centers, K1, K2, and K3, and the different points that have been allocated to them. For example, you can see these points have all come to this cluster center K1. These points have been allocated to K2, and these have been allocated to K3. Now, what we'll do is that after the first iteration, when the points have been allocated by finding out their distances with respect to K1, K2, K3, the next step is we'll now again find out the mean of all the points in a given cluster. So all, for example, all these green points will be used to find out the new means. Okay. The means could remain the same or it could shift. In this case, this is the previous mean of K1 and it is actually shifting to this new K1 shown in the bold color. Similarly, this is the old value and it has now shifted to K2. And then this is the old K3, it has shifted to this, it is the other way around. This is the old value and it has shifted to this one. Okay. So now, on the basis of the mean of all the points, we have now found out the new cluster centers which are given as K1, K2, and K3. Now, once again, what we will do, we have found out the means again. We will now again find out the distance of each and every point that we had assigned earlier, even if it is assigned to K1 or K2 or K3 cluster. We'll once again find out the distance of each and every point with respect to each and every cluster center, the new cluster center. Say, for example, we'll find out the distance of this point with this new cluster center, this point with this cluster center, and this point with this cluster center. So you can see here, previously the cluster center was here and therefore this point was closest to this cluster center. But now you can see that the distance between this point and the new K1 is larger than this point with respect to K2. Or in other words, once we have iterated with the new means and then we are trying to find out the similarity or the distance between the points and the new cluster centers, some points might change the cluster. And this point is one such point. So what will happen? This I've already shown you. So now this point is one of the points that might change the cluster center. Similarly, if you look at this point out here, right? This point was initially assigned to the old cluster K2 because the distance was least with respect to K2. However, now we will have to see whether K2 will this point will continue to belong to K2 or it will move, and so on and so forth. So if we try to look at these 3 points, what we will observe is that now K2, so some of the points would have changed. For example, this point out here. This point was previously very close to K1. Now it is supposed to be closer to K3. So it is now assigned to cluster K3. And if you see here, these were the clusters. You can just try to look at the shapes of the cluster. And after iterating over the new means and all, what we have identified, these are the new clusters. Okay. So like that. Now again, since the points have been reassigned, we'll once again try to find out the new means, okay, and see if the new means is different from the older one. And then again, it can happen that this K2, after assigning or reassigning of these points, can move somewhere. Maybe the new K2 may be here, maybe the new K3 may be somewhere here, and maybe new K1 maybe somewhere here, like that. So we'll have to actually again find out the new means and then find out the distance of all of these points with respect to these new means, right, in the next iteration, and see if points are again changing the cluster. And we'll go on iterating this again and again till substantially there is no movement of points from one cluster to the other. At that point in time, we will stop. So the stop criteria will be that substantially the points will not move across clusters, or if we have decided some cap on the number of iterations, then after that many number of iterations, we'll have to stop. So it is important to point out that if there are a large number of points, say we have got some 1 million points, then the iterations that it may take to converge the clusters can be extremely high, and it can be very compute intensive also. Therefore, in most of the uh, you know uh, in most of the times, we try to put a cap on the total number of iterations for which this algorithm is going to run, and at that point we assume that the result is good enough for us and we stop. So this is how k-means proceeds. So you can see here again, as I mentioned, the means might shift further and the allocation of points might further change, and so on and so forth. So this is the entire process shown together. Initially, this is the data space, for example, given to us, and the points are shown in these two colors. The initial random, cluster centers are shown in these two red circles, and k is equal to 2, let's say, for example. Then, after this initial allocation of the points, the clusters would look like this, as you can see here. Now, after doing this, we'll have to find out the new means of these 2 points, these two clusters. And let's assume these means are as shown in this figure out here. And then based on these two new means, we have to find out the distance of all these points with respect to each of these cluster centers. And then a point might shift from one cluster to the other. For example, this point earlier was closer to this, now is closer to the other cluster center. So now this point has shifted to this cluster, like that. And we go on doing this, we update the clusters, then update the cluster centers, and go on doing this till substantially points don't move. Okay, so this is about clustering. So let me stop here and invite questions if any. So I can see your hand raised.
Ma'am Sumitra here. Can I go ahead?
Yes, yes, yes.
Ma'am, can you just explain me like how we got the new K? Actually, somehow I didn't got that one. I understood until K1, K2, K3, but what is the criteria? How we define the next K?
The next K. No,
Yeah.
here we are, so in K means this value is fixed.
Okay.
Okay. So in this example, it is fixed to 2. So you
Hmm.
can see the number of clusters will be 2 all through. What will change will be the means.
No, no, ma'am. The previous slide one, like
So
where we have the
yeah,
cluster
so
and then we're finding a new K, right? K1, K2, and K3. Now the K went to that red one. So like, how do we find that K?
okay, so here this actually means the cluster center or centroid. Okay.
Okay. Hmm.
And the same thing we were doing previously also. How do we find out? Let's say in this round,
Hmm.
okay, we have these cluster centers as shown by
Hmm.
this K1, K2, and K3. Once
Okay.
we do this, then we are going to find out the distance of each and every point with respect to these 3 new cluster centers. Okay, this we have to do for each and every point. So
Okay.
for each point we have to do. then it is possible that some of the point may now be more close to, in place of K2, it may go to K3. Say, for example, if there is a point like this, probably it may have been with K2, it might go to, I'm just giving an example. So for each and every point, we have to find out the distance of the point versus these three cluster centers,
Mm-hmm.
and then decide which point will continue to remain in the same cluster and which point might change the cluster based on its closeness to the new cluster center. Okay, like this, points might change. Okay, then after the points have changed, we are again going to calculate, let's say these are the new allocation of the points. Okay. Now,
Okay.
given these points, all these points in a cluster, we are going to use to find out the new cluster center once again, because the points are changing. Therefore,
Mm-hmm.
the cluster center is nothing but the mean or the average value, so it will change. So every time we have to go on doing this till substantially the motion of the points across the cluster stops.
Okay.
Is it okay?
Yeah, got it, ma'am. Thank you.
Okay. Next.
Ma'am, this Meghna here. So,
Yeah.
can you explain like how the objective functions work internally to determine the value of k?
Okay. So, the value of k, as I told you, actually is an input to this process, right? So k is actually an input. And what is k? The number of clusters. So either we have to know what are the optimal number of clusters that will be available in the given data. If we have prior knowledge, it's okay. If we don't have, which usually we don't have, then we have to decide it. So what we do is that we plot a graph between the different values of k versus the objective function. Let's say the objective function is some error. Okay. So for each each value of k. So k equal to 1 means we are going to have one cluster only. If k is equal to 2, we are going to form two cluster. If k is equal to 3, we are going to form three cluster. And in each case, we are going to find out the difference or the value of this error. And whatever that error is, we'll plot it. Say, for example, at 1, the value of the error is this much. So we plot it here. At 2, it is this much. 3, it is this much, and so on and so forth. And we plot a graph. And then we identify what is the change point. So this is the change point. So we take this value of k as the final number of clusters that we are going to form. Is it okay?
Ma'am, what is this error functions like this? For example, if this is a particular scenario of elbow curve, so what is that function? I mean, when we say like, okay, there are say 100 data points and k is determined as a 1, 2, and goes on, right? So how does that work? I mean, like,
Uh,
does it
okay.
iterates the complete clustering process on top of it, and at the end, it determines the error value, and then how it is, plotting the number of k's against the error? So, how does this work? Is it like a clustering methodology within itself so that it can determine the error at the end of it? So, that's what my question is
Okay.
about.
Yeah. Okay. In a way, what you are saying may be correct. But we'll not consider all the iterations. Let's say it's like this, that, this is your sum of square error. What is it? It is like, if we are talking about any 2 points, we have to do for all. I think I have a slide on this. Let me go there. It will be
Yeah,
more
something
clear.
WCSS score, ma'am. She's trying to ask. We have something as WCSS score.
Okay. So this is what your sum of square error looks like. So if you are talking about some ith cluster, okay, this is the centroid or the center point or the mean of the ith cluster. This is any point x inside the cluster I, okay. And what we try to do is we find out the distance between the centroid with respect to all other points. Let's say these are the points, okay, that we are having. And this is the cluster center. So within the cluster, we find out what is the difference of each and every point with respect to this cluster center, which is the distance here, and then we square it, and we repeat this process for all x, means all the points. So we do this for all the points, right? So and then repeat this process for all the clusters. So if we have k number of cluster, then we are summing this. So what does it mean? It means that the average value is the most central value, or it is the cluster representative, right? So, or in other words, we are forming a cluster, right? And this cluster center, or the mean value, or the centroid, is probably the cluster center, or it is the value that is representing the cluster. Then all the points, how far they are from this mean value, is actually the error, because if this cluster was a ideal cluster, then all points would have overlapped in it, and the mean would be same as all the points itself. However, the mean is different because the points are distributed in this fashion. Therefore, we find out what is the distance of each and every point with respect to this cluster center, and then square it, and then add all such distances, and then do this process for all the clusters. So this is the summation on all the clusters, and this is your objective function, which is sum of squares of errors. This is a square of errors. This is a sum over one cluster. This is the sum over all clusters. We want to minimize it, or we want, in other words, we want compact clusters where all the points are very close apart, right? So that this error is reduced. This is what is your objective function. So now when we take a value of k equal to 1, let's say, and I can show you with this example here. Right? Here, given these set of points, I took k equal to 1. Now I'm going to find out the value of the objective function. You can see if k is equal to 1, the average of all these points is coming out here. Then in the sum of squared error, what will happen? We'll find out the distance of each and every point with respect to the cluster center, which is the cluster representative, and square it and add all these distances, right? I'm not showing all of them because it will look cluttered. And this will be the value of your sum of all these distance squared and added together across all the points will be the objective function value. It is coming out to be this much. So then the next value after k equal to 1 will be k equal to 2. K equal to 1 I showed previously. Now this is k equal to 2. In this case, we are having two clusters, okay? And let's say we are assuming the mean value as these. Again, we find out the distance of all these points with respect to its own cluster center. Write that like this. And in this process, you are actually doing a clustering with value of 2. So what you said earlier, that we'll have to do the clustering with so many number of clusters, that is correct. And then the sum total of all these squared distances for this cluster and this cluster put together will be your SSE with k is equal to 2. Then we do it with 3 and all that like that, and then draw this graph and then choose the optimal number of clusters. Is it okay?
Okay, ma'am. One follow-up question to this only. For example,
Yeah.
you could do k equal to 1 and say k equal to 2, and then you on what basis those points are getting assigned to each of this k1 or k2? Because once you are assigning it, then that interpoint distance is being calculated, right? So how even it calculates the distance even before that, how they are grouped?
Yeah, initially I told you it is a random grouping.
Okay.
Here I've shown you, see, I told you that let's say if k is equal to 2, I just chose cluster center C1, C2, I just randomly assign any point to any cluster like that. This is just a random allocation. Once that allocation is done, then you use the points to find out the means. And this is how the cluster centers come into picture. Okay. So initially it's always a random allocation only, and there's no other starting point.
Okay, so even if we keep on increasing, say K1, K2, K3 based on like the previous facts, still for the next mapping, it will go ahead with the random sampling itself
No,
across
no,
complete. No?
that's incorrect. So the first time you assign,
Mm.
let's say I start with see k equal to 1 is no allocation, so I will not go with that. Okay, this is only used for calculation of SSE. The allocation begins with k equal to 2. So initially, let's say these points, though they are looking correct, I randomly assigned them to 2 clusters. Okay. Now, having assigned these points, I'm going to use all the attributes of the points to find out the value of this mean, right? Let's say I'm having 2 attributes only, x and y, because this is a 2D plot. So for all the points, green points, I'm going to find out this x1 plus x2 plus whatever the number of points are there, let's say xn1 points, I'm going to find out a mean. Okay. And similarly, I'm going to find out the mean for the y. For all n1 points, if these are n1 number of points, and based on that, this point will be the mean point. This is what is the point. Similarly, for all these points, again, I have to find out the mean of all the attributes to find out this point. Now, after I have found out these 2 points, this will be the means. Once I find out this means value, then what is happening? This random allocation of points might change. So if this was random, it might shift to somewhere here. Okay. And this might shift to somewhere here, let's say. Now these new means are taken as the new cluster centers. And once again, the distance of each and every point in the cluster and other cluster also is calculated with respect to these 2 new cluster centers to see whether the point will continue to belong to the same cluster or it will move to some other cluster, which I had illustrated better way with the help of this diagram. Right? For example, these were the 3 initial cluster center. If k was equal to 3, we randomly assigned some points. This was a random selection. After doing this random assignment, I'm going to find out the actual means of all the points that have been assigned to this red cluster, green cluster and all. And then based on that, the cluster centers have changed now. This is the new means. This is the actual means. Okay. And this is what I'm showing. Okay, so the cluster centers are moved to the new actual means. Now again, we'll find out the distance of each and every point with respect to these 3 new cluster center if k is equal to 3 and see if they are getting reassigned. In this case, some point might get reassigned. As you can see here, these are the 3 new cluster center and these are the points which are on the boundary of the previous cluster. So now we'll study these points. We'll see that now this point was earlier belonging to this cluster has gone to now K2 cluster, like that. And we'll go on iterating till the movement of the point substantially doesn't happen or the total number of iterations have got completed. Is it okay?
Yes, ma'am. But my question was more towards how the k value increases from 2 to 3. Like this is about like we are aware now like how many number of points will be there, and then it goes through this iteration of reassignment, right?
Yeah.
But my question was more towards the sampling that happens when the value of k increases. Maybe this is a part of the objective functions again.
Huh.
When k increases from 2 to 3, then how does grouping happen so that it can calculate the new distances?
So this whole process needs to be repeated with k equal to 2, k equal to 3, k
Okay.
equal to 4, 5, like that. And then we draw a graph and then finalize on the value of k.
Okay, that's the instant. Okay, got it. Thank you.
Okay. Next, please.
Hi, ma'am. So
Yeah.
the knee diagram is basically, like we manually, or is the same as manually, like we're running the clustering algorithm multiple times for each value of k, and then plotting the final SSE values, isn't? So both are
Yes,
same.
yes, exactly, exactly. So you repeat this whole process again and again with different values of k every time you find out SSE and then draw the graph and find out the knee, and that will be the final value that you will choose for the number of clusters.
Okay. So in the clustering, is it going to be the first step, or is it like, or there's an algorithm which will kind of take, when we run this chart, will automatically in the underlie, will do the clustering for value and it will plot, or is it some manual activity to plot this?
It can be either way. It depends purely on what you want to do. There can be pre-coded functions that will decide the value of k, but usually this has to be done by code. I mean, The standard function in Python for k is not going to do that. It requires an input of k value. So you'll have to do this plot, then decide the final value of k, and then give that as the final clustering value.
Okay.
Okay.
So we need to do the clustering algorithm for different values of k,
Yes.
get the SSE and store it in data frame, and then plot it, and then understand which one to choose.
Correct, correct. Yes. Okay, next please.
Hi, ma'am, Ashish here. So I understood it, but just one question. In the very beginning, when we pick the random point, do we have, so what happens if points are very nearer? So it will increase our computation time, right? So do we actually do it randomly, or it has to have some strategy even if we go in the random way for the very first initialization of, let's say 3 points are there, where to keep them? Now, if they're
Okay.
far, then it's good, but if they're very near, then the computation time will definitely increase. That's what I'm thinking.
So, as per what k-means goes, it is random in the first step. However, you could refine it by having some strategy, if at all that strategy works on your set of points. Because the k-means in its form is generic. That is, you can apply it on any given set of points. And as you are talking about a strategy, given a specific set of points, the strategy may be different. So that's not part of the standard k-means, but it can sit on top of k-means.
Okay.
Okay, next please. Vipul, did you want to ask anything? Okay, if there are no further questions, then I'll proceed with what we were discussing. Okay. So now there are certain things that we need to know. Say, for example, since the initial clusters are chosen randomly, therefore, this random choice. So you see that the initial choice of the cluster uh, center can substantially, the difference in the initial choice could vary the final cluster's form. Why this can happen is, I will show you in some of the slides in future that how this is going to impact the initial choice. So we have to be very careful also about the initial choice, not just about the total number of clusters that we are forming. And if our choice goes wrong in any way, then our final clusters may land up incorrectly, right? So this is one thing to be noted. I already showed you what is k-means clustering. These are just some of the pseudo code, so I will not discuss it, all these steps. Okay, this is the complexity, that is the runtime. So the runtime may not be clear to many of you. So those who are interested can understand that this is the runtime or the complexity in terms of the runtime. It is of the order of nkid, where n is the total number of points that we are having. K is the number of clusters that we are going to form. I is the number of iterations, and D is the number of dimensions or attributes. So this whole process is proportional to the number of points, number of clusters, number of iterations, and number of attributes. Now, the number of clusters actually is a constant given a clustering process. The number of iterations also could be some constant value that we can pre-specify for the algorithm to proceed. The number of attributes obviously is also fixed. Therefore, all these are fixed. So you can say that the order of time is dependent on the number of points. So actually, this particular algorithm, though it looks very compute intensive, but it is much, much less compute intensive as compared to other algorithms. And that's why it is a very, very, very popular clustering algorithm. Only thing to note is that you should be very careful about the total number of clusters that you choose and many other factors that we will discuss as we go along. So now, having discussed what k-means is, do you foresee any problems uh, in the way k-means is proceeding? Anyone?
I think, ma'am, the initial points, the randomly selected points, if that is skewed, maybe it will take a lot of iterations to come to the proper clustering.
Yeah, that's okay. That the initial cluster choice might impact the number of iterations. In fact, I already pointed out that if they are very incorrect, then the solution might never converge to the correct solution. So that is one important problem, the initial cluster center choice. Yes. This is one important problem. Any other problem?
Outliers, how would outliers impact the clustering? They can distort themselves.
Okay. The impact of outliers. Anything else? Okay. The first and the foremost important thing out here is uh, the requirement for the value of k, isn't it? You need to have the correct value of k always with you. If you don't have any estimate on the value of k, then what can we do with k-means clustering? Nothing. So this is very critical requirement, and that is the input that needs to be given. So either we have to iterate through so many values of k and draw the objective function and do all that. Otherwise, we need need to have some prior information about k value. So this is one important limitation. The next limitation, of course, is
Scalability, like because data is high and then we have to keep on doing the clustering, so the scalability will be issue, right?
scalability is not an issue because this method is meant for large number of points. Only thing is the amount of iterations it may take may be large. That is the thing. But
Okay.
the method is scalable because any algorithm whose performance degrades with increasing number of points is said to be not scalable. But this doesn't happen here. Its performance remains the same with the number of points increasing. Okay. So that's not an issue.
Okay.
Then there are many other things that may be noteworthy. The value of k, the outliers. Then we'll think about this thing slightly later. Density of points, etc., etc. So we'll discuss some of these points as we go along. So the first thing is how the initial cluster center choice will impact the clustering. Let's say these are the points and the colors show the natural grouping in the data. And let's say we know the correct number of clusters also, and the optimal clustering with a value of k equal to 3 looks like this one. If the the cluster centers, so here accordingly the cluster centers might have been chosen somewhere here and they converged correctly. But if the cluster center choice was done in such a way that there was a cluster center chosen here, here, and somewhere here, then what it could give? It could give clusters like this. So therefore, the initial choice of cluster center is critical to this process, not just the number of cluster. Here, the number of clusters, as you can see visually, is 3 only, which is a correct number. However, by specifying the initial random cluster centers substantially incorrectly, it will never converge to the correct solution. That is one thing. So, of course, uh, the way we do is that we'll have to repeat the entire process multiple times to infer whether the choice of the initial cluster center is correct or not. Okay. So now, before we proceed, yeah. So now I'll like to discuss one thing, that the sum of squared errors, which is given as this, actually what is this? It is going to look at the distance of the cluster center, if this is the ith cluster, with respect to any point in the cluster, and then it will do the square of all these distances and do a summation of all points belonging to the ith cluster, and then sum all these values for all clusters. So this is how the objective function is working, right? Now, given this objective function, what comment do you have about the value of k? See, I already told you, assume we don't know the correct value of k, and we are required to draw a graph of the objective function, which is SSE versus k, to find out the knee and choose those many number of clusters as the correct value. So any comments on this?
Ma'am, higher the value of the K, the overly trained our model will be. So we shouldn't give the higher K value.
Okay, so I'm saying that the k value is decided by this kind of a graph I told you, where we have the value of k, SSE drawn versus k, and we find out the knee of the curve, and then use the knee as the final value of k. And this is the objective function, which is used on the y-axis, right? So now what happens is that in this objective function, we are trying to minimize this distance. And what is this distance? Let me see. Okay, so what is this distance? Let's see, we are having these set of points in a cluster, and maybe we are having these set of points in another cluster. Okay, and let's say these are the cluster centers, and we want to find out the distance of each and every point, right, of each and every point with respect to the cluster center. Like that, this is the distance of each and every point with respect to the cluster center, and then square it and then add them and then do it for all the clusters. Let's say now, I think I'll have to use the eraser to illustrate what I want to illustrate. Give me a minute. Okay, now let me choose another set of points, and in this set of points, so suppose this is the distribution of all the points in the data space. Okay, this is a 2D data space. Fine. Now, the objective function needs to be minimized. That is the error or the distance between the cluster center and the rest of the points in the cluster needs to be minimized as per the objective function, which is SSE, sum of squares of errors. So how can we do that? So you can see visually that there are two clusters here. One larger cluster is this one, and another cluster is this one. The larger cluster is a little sparse and spread out. the smaller cluster is a little dense and packed. And let's say I have the correct value of k equal to 2. So how the sum of square errors will work internally? The sum of squared and the sum of squared error knows that it needs to minimize this, the distance of each and every point with respect to its respective cluster center. In an attempt to do that, actually, the correct cluster center for all the points here in this portion should have been here, and in this portion, it should have been here. But just to reduce this, what it will do, it will assign some of the boundary points here, because it's possible that the distance of this boundary point with respect to this is larger as compared to this one. This may be smaller and this may be larger. Therefore, it should have assigned this point to this cluster center, but it will assign it here. Why? Because this distance is less. Because this happens automatically because of the way how sum of squared error works. So to achieve a global minimum of this expression, it will prefer a large number of small clusters. If there are a large number of small cluster, definitely instead of having just 2 cluster, had I got 4 clusters like this or 3 clusters, then definitely the points would be split across this, and the distances here will be much less, right? The sum of these differences will be less because the number of clusters are higher, and so the distance of each and every point with respect to the cluster center with higher number of cluster center will be small, and therefore the error will be reduced like this. So this particular objective function favors a large number of small clusters, okay, because this is the way it works. And so therefore we need to be careful on the number of and of course when we do this we are actually overfitting the data, because instead of forming one large cluster by a set of points, we are splitting that larger group into large number of small clusters. So we have to avoid overfitting, and there are ways to do that. We'll discuss as we go along. Okay. So then coming back to the limitations, as I already mentioned, K-means, though very popular, suffers from a large number of limitations. I already discussed some of them. It requires the value of K in advance. It doesn't work well when the random selection done for the initial cluster centers goes incorrect. Then it doesn't work well when the data is noisy. Why it doesn't work well? Because the cluster centers are utilizing means or average value of all the points inside the cluster. Because it is based on average, so if there's noise in the data, it will substantially change the means. Say for example, let's say if I have some set of points here, and these are all the normal points like this, and there's another cluster, these are the normal points. But if there's one point here and maybe one point here, now as per this method, each and every point needs to be accommodated exactly in one cluster. Therefore we cannot leave out these noise points, and let's assume they got accommodated like this in cluster. Then this point is very far away from the rest of the points, so it will actually, the mean might have been here, but it will shift it to this point probably, and this mean might get shifted here. It should have been here. So the means will get impacted. Therefore, this method is not robust to noise. Okay. Further, the notion of, because k-means relies on the center of a cluster or centroid, so therefore it's useful only on numeric data, because we don't have a notion of cluster center for categorical data or other data types. So it works only when we can represent the data with a cluster center, in this case which should be numeric. Now I'll talk about the rest of these 3 points as we go along. So the
One
first
question
point,
here. When
so I'll invite questions in some time, Shashank. So let's come to the first point, that is clusters of different sizes. So k-means has a problem when the total number of cluster has different sizes. For example, in this particular data space, you can see these 3 clusters in 3 different colors. The size of these 2 clusters is almost similar, whereas this cluster is a large cluster. It has a large number of points. Now, the way clustering operates is that it, it decides on a cluster center and tries to minimize the sum of squared error. So, like suppose the cluster centers were here, they should have been here. In this case, the sum of squared errors would be minimized for these two, but they won't be very less for these set of points because there are a large number of points and this is a large cluster. So distances between the points and the cluster center will be high and therefore the SSE value will not be optimally low. So how k-means works is it tries to divide into the given data space into equal number of points so that all the points are equidistant from the cluster centers. So what it does, it puts equal number of points in one cluster, some equal number of points in another cluster, equal number of points in this cluster, and these are the 3 cluster center. Now each and every point is almost at a equal distance, you know, with the cluster center. So this cluster has some points, say X number of points in its vicinity and Y number of points a little far away. So this will also have approximately X only near to it and Y far away. Similarly, X, points may be close by and Y within the cluster may be far away. So more or less, the distance between these 3 cluster points and the respective points in their clusters is almost the same, or in other words, the sum of squared error here will be minimized because the clusters have been broken or made in a different way. So actually a bigger cluster has got broken into 3 smaller parts and they have got merged with some other cluster. So this is a wrong way of clustering, but this is how sum of squared error works to, in case of k-means, and therefore k-means doesn't work well if the clusters are of different sizes. So you should know that if you are using k-means, your clusters should more or less be of the same size. Otherwise, the clusters formed will actually be not a correct representation of the actual clusters that are there in the data. Then you have different points with different density. You see a sparse region here, densely packed regions here. So as I already told you that SSE needs to be reduced. So if I put one cluster center here, one here and another here, the SSE in this cluster will be high. Why? Because points are quite far away from the cluster center, but this is the correct way to cluster. However, to reduce SSE, what it will do, it will break this cluster into, if k is equal to 3, which is the correct value, even if it is the correct value, it will divide this bigger cluster into 2 smaller clusters and put all of them together in one cluster. Now what happens? These distances, because this one single cluster center was far away, so it would have been high. Now they get halved. So this cluster center becomes closer because there are 2 cluster centers. So now each of them are closer relatively to the points. So SSE gets reduced and all these points are so much packed and the clusters are near to each other. So more or less the sum of the SSE of these two versus one of this will be almost the same. So in this way, the SSE gets reduced in k-means. So this is actually a suboptimal clustering, but this is the way it actually happens when k-means is applied to data having different densities. Now, k-means is also, much applicable when the data is having circular, spherical, or non-globular shapes. For example, see, remember what I told you is when we talk about k-means clustering, it uses a notion of centroid, and all the points around it are placed in the respective cluster, right? So in a way, we are looking at a center and we are looking at some radius, right? And all the points within the radius will belong to the same cluster like that. So there is a notion of centrality which requires the points to be organized in circles or spheres or whatever dimensions it is. for k-means to be successful. Now let's see this set of points. The original clusters are shown in these two colors, orange and red. This is the correct clustering of the points. So these are not circular in shape. However, and since there are two clusters, the correct value of k is equal to 2. However, when we apply k-means clustering and SSE comes into picture, what it will do, it will try to divide these set of points so that equal number of points come into this, and so the number of points equidistant to this and to this cluster centers are almost equal, so the SSE gets reduced. So in an attempt, it will split across these two clusters and incorrectly merge two parts of the cluster in one cluster and another two parts in another cluster. So therefore, k-means doesn't work well when the shape of the cluster is not non-circular, non-spherical, and non. So this is just a summary. So advantages is it's quite interpretable and it's efficient also. However, the disadvantages are like we need to specify the value of k in advance. Then it is not able to handle noisy data or outliers. It is sensitive to outliers. Then we can use it on numerical data where the notion of means holds, and it is not able to find out clusters of arbitrary shapes. Okay, so these are some of the disadvantages. So now I'll uh, invite questions on k-means, if any.
Ma'am, Sumitra here. Ma'am, can you
Hmm.
please give us an example, real-time example, how we can see this data and real data?
How we can visualize the data, you are
The real
asking?
data, yeah, with the cluster of a example of any e-commerce or any related real industry things, so we can visualize like how actually we do that.
I couldn't get your question. Are you asking that if you are given a data set, how will you visualize it?
No, no.
Are you?
Pardon me, my voice is not good. So right now we have a, blue color code data, right? So these
Mm-hmm.
are like we are just visualizing. Okay, these are
Mm-hmm.
classified with red and green, and this is
Yes,
how we are
yes.
getting. So can you give us a example
Okay.
of real time so that we can visualize? Okay, this is how we cluster it. Somehow
Uh,
I got the logic, but I'm not able to correlate like how we can do in the real time.
okay, okay, fine, fine. So for I can give you an example. Let's say we are talking about this data space.
Mm-hmm.
Okay. And this represents a locality. In the locality, there are some communities. So this is one gated community, this is one gated community, and these are some separate standalone houses,
Okay.
bungalow type.
Mm-hmm.
So these communities are having lot of flats which are clustered together, right? So you can think of these gated communities, they are multi-storied apartment complexes. So large number of households are here, whereas these are bungalow type. Therefore, fewer number of houses may be there in this locality, right? So this is a real world example. Let's say if you are talking about some property values,
Mm-hmm.
then these are apartment complex, multi-storied apartments. So lot of people, lot of house owners are there, which are represented by these circles, depending upon the ownership of the flats. Whereas these are the owners that own bungalows. So, and bungalows are not built on one on top of the other, right? They are far apart. So
Correct.
this is the density and this is one locality in any city.
Okay.
Okay. Okay. Any other question? Next, please.
Ma'am, do we ever merge two clusters, or is there some custom work that people do over k-means? Because if we go with a traditional pattern, then we will not know what does a cluster mean, and are we even you showed couple of examples where it is not centroid, notion is not centroid, but we cannot visualize that in the real time, right? Because graph will be too complex for millions of rows. So how do we do it there? But for small data, I can see that there's a shape. You're clearly saying that it is not uh, able to distinguish between actual clusters that should have been there. But
Mm-hmm.
But how will we know this in the real time? I mean, with the real data, because there we won't see this kind of graph every time. If data is so much, maybe it's not of this shape. There, how does it work?
Yeah. So that's why we did the pre-processing earlier. Remember, if we have a large number of points and you really want to see what the point distribution looks like, you'll have to visualize it. And to visualize it, you may have to reduce the number of dimensions that you can do with the help of PCA.
Okay.
Okay. So
Okay.
once you use PCA, then you reduce the number of points to 2D or 3D and then visualize it and then see what is the distribution of the points. And I'll be showing it with the help of some real world. As you know, in all the hands-on, we've been choosing data. Whatever you have chosen are real data sets, which have been archived as open data sets. So I'll be showing also in the hands-on. We'll see visualization of points as well. Similarly, you can do.
And ma'am, there's another question which is just like what Sumitra asked. So I have worked in an organization where my team used to create these clusters, but I don't know what do they do after that. So they were e-commerce. So I want to understand, if we make clusters, okay, let's say I made 3 clusters, then how would I know what does this cluster mean, so that I can, later on do something on the basis of this cluster? What is the next step? Suppose I have
Yes, yes.
customers, a lot of customers are there for e-commerce website, and I did a clustering and I made, let's say, 5 clusters. Now, what is the next step? Probably people will do
Yeah.
that. Can you just help me with that, so that I'll visualize what
Yes.
exactly this helping to? Yeah.
Yes, yes, sure. So I'll make this a little clean to help explain. Okay. Give me a sec. Okay. So what will be the, how you will actually think, or, how you will interpret what is inside the clusters once having formed it. So you remember that we discussed that clusters mean points which are similar to each other, right? So let's say that in e-commerce, you are having uh, people who are buying similar products. Or I should not say this, you are having some set of individuals who are buying certain set of products. Okay. And the set of products that they buy and the numbers that they buy represent their sales on any particular instant of time. And we cluster the sales data. Okay. And we find out this kind of, let's say, this kind of patterns in the sale. So these are, let's say, some items that are getting clustered. Okay. Just you can think about it, that you are clustering the sales, and in sales, these are the, buying patterns. So people who are in this cluster buy similar. So what it means, let's say you have formed the clusters based on the items purchased by certain individuals. All these points represent those individuals. So then if I look at these set of individuals, once I form the cluster, what I want to do with the cluster is that I then look at all these people and drill down what are their, profiles like. Probably if, let's say, this was the price of the product, so these are the people who are buying kind of low priced products. Probably these are the people who are buying budget priced products, and these are the people who are buying high priced products, right? This is one simple thing. Other than that, I can also look at the profiles of these people. Probably these set of people who are having a high purchase value, they are making high value transaction, might be having high income, and these may be having low income, and these may be the middle class people. Now accordingly, in e-commerce, now I can target the products, right? I'm having some niche products, I'll make a target for this group. I'll have some budget products, I'll target these set of people. And if I have some low price products or some very good offers, I'll target probably on this group. So this is how, this is one example how you can use clustering in e-commerce. Is it okay?
Yeah, thank you, ma'am.
Any other question, anyone? In the end, we'll take up discussion on formation of groups once we are done. Any other
Can we-
question? Yes.
Can we choose the centroid by visually plotting the data? Initially, we want to do it.
So even if you visually plot the data, then you want to say you randomly choose some point in between that data space as the cluster center. That's what you want to say?
Yes, ma'am.
Yeah, you can.
Initial choice by seeing that where initially we can choose the data by visually taking the centers of the data points.
Yeah, you can do that. If your data is such that you can have some clear clusters, you can visualize it, and then with the help of those clusters, cluster boundaries, you can identify some middle kind of a point and then choose it as a cluster center to improve your clustering process. You can do that.
And ma'am, is it necessary to include all attributes in clustering, or we can drop some attributes also?
So to include all or to drop one, that will be part of your pre-processing. Remember, we can always do a feature selection also. If we feel that there are certain attributes which are irrelevant or they are, they are behaving similarly to some other attribute, so they are redundant, then you can drop them also. But that will be part of your pre-processing. After doing all that only, you come to the actual part, which may be classification, clustering, or anything else.
Okay, ma'am. And ma'am, last question. Ma'am, this k-means clustering can also be for the dynamic data. So is it not that so compute intensive that every time data enters and the distance is to be calculated from all the centers?
Okay. So first of all, you said that it is applicable to dynamic data, right? But you look at, let's say this is the data space. You are having all the points in advance. You look here, you look at any example, all the points you wanted to cluster are there in advance only. There are no incoming points. If there are incoming points, then you'll have to redo this whole thing again and again. So k-means is not meant for dynamic data, and I told you that as a disadvantage already. It requires the complete data in advance. If you have points coming in or you have data that is evolving or it is dynamic in nature, then you have to do this whole process again and again, and that is very compute intensive, as you already said. So it's not useful on that.
Okay, ma'am. Thank you.
Yeah. Any other questions? Anyone?
Ma'am, for this to select the optimal K for the clustering, we are using this elbow method, right?
Yes,
So,
correct.
and there is one more, I think, this Silhouette score.
Yes.
So, if you can tell us about this little bit, would be good.
Yeah, so I will cover Silhouette score in the next turn before the hands-on. Okay, I will do that. So
Okay,
that
okay.
is, there is another way of looking at the compactness of the cluster to decide whether the compactness of the cluster is good or not. So I will discuss that. You'll
Okay,
have to
fine.
wait a little bit. Yeah. Any other questions? Anyone?
Yeah, ma'am, I had one question. When we were dealing with the noises, right? We have calculated the mean. Why didn't we opted for median at that point of time?
You are saying
While
in
following-
K means is used and not median.
Yeah.
Is it what you are
Yes.
saying?
Yep.
Okay. So, see, this whole algorithm is based on the centroid, notion of centroid, and the centroid is here calculated using means of all the points. Okay. There are other algorithms that can utilize median also, but they are not popular because it's a little difficult to find out median. It's much easier to find out means. So k-means is much more popular, though there are algorithms that follow the median also. And it's called k-meteoids, but I'm not covering it here because it's not popular at all. No one even might have heard about it. No one uses it. This is the one that is most common, and that one is very, very compute intensive, because to find out median is is much more compute intensive than to find out mean.
Okay.
Ma'am, the last one it says like the not suitable to discover cluster with non-convex shapes. So the reason is being like we are not getting the mean correctly. That is the reason we cannot use those kind of data set.
I already showed you. See, for example, this is the arbitrary or non-convex shape here.
Mm-hmm.
But the way k-means works is it utilizes the notion of a centroid or cluster center, which is the mean value. So it cannot, how will it work on this data? It cannot find a mean of this,
Main of this.
because mean will always have the notion of mean, and all the points within the radius are going to be the part of one cluster. So it will form clusters like this. So therefore, it's not very useful for this kind of arbitrary shaped data. It's good for data which is having this kind of shapes. Okay. Anyone else?
Ma'am, one last thing from my side.
Yeah.
When you mention that uh, this particular clustering way is not relevant when we have like the continuous data, when we are getting new data often. So when Ashish asked about that e-commerce thing, so for the forecasting of like how they will, the sales will, or the other things, so because it's a continuous process, e-commerce website and all the things. So is it relevant to apply this clustering over there, or
Yeah, it is relevant because let's say that a new product is to be launched, right? And that new product needs that advertisement needs to be targeted on some set of customers. So to target anything on some set of customers, some prior information is required, isn't it? So that prior information is the prior sales data. So there you are not having, see, once a product is launched, then you try to give the advertisement, or you launch some advertisement campaigns depending upon the uh, prospective customers. So it is done at that time only. So here there is no continuous process. However, there can be e-commerce applications that might require dynamic data inputted to it. So for such cases, this will not be useful. It is useful only for cases where we have certain data and we make the inference on that data and use that inference to do whatever we want to do. Say in this case that I gave, we want to launch some target certain set of customers for a certain type of product. Then we should have some data about what was the sales in previously. Based on that, we target those set of customers who are buying high value prices, and so on and so forth. So
yeah?
it is like that.
And just to add, uh, after the clustering, we used to get a coupon and customer cluster file from the data scientist team, coupon and customer, and so I think
Yeah.
probably they were assigning some coupon to the clusters. So that file we used to get from data science team after this
Yeah,
clustering.
so I already told you, right? The I said that you have this, the let's say the amount of sale, and based on that you are going to target the customer, and you'll have a look at the profiles, and based on the profile you'll see the buying habit also. Probably these people who are buying low price product may be buying certain category of the product, or they may just be buying some commodities, right? And so accordingly some coupons may be generated, and they may be distributed so that new products can be launched, right? There are some new brand on some commodity, maybe a new kind of a butter, bread, or something. Then coupons will be given to these people who are very frequently buying that kind of product. So they will see, okay, they are already habitual to buying low priced products. And if you give a discount coupon on the product that they kind of product they buy, let's say some consumer product like bread, butter, jam, and all that, then they'll be very much, swayed to buy it because it's further going to bring down their cost. Whereas these niche customers, they are habitual to buying high priced products, let's say certain branded perfume. So these people may not find a discount coupon very lucrative because they are more inclined to buy a quality product, or they are more inclined to buying certain unique product. So accordingly, the coupons may be generated. So already I gave you that example, Ashish. Okay.
Yes, ma'am. Thank you.
Yeah, ma'am, one question I have.
Mm-hmm.
So currently, on the customer segmentation, we can use this clustering approach. Suppose
Mm-hmm.
we have a set of articles and we want to cluster them into different categories, like whether it's a sports, political, or entertainment news. Can we do that?
Yeah, surely. This is also another very important use case. So you have a set of documents. Let's say I have an incoming new document and I want to put it in the correct category. Obviously, then I'm not going to have a look at, all the documents that I have. So the way it happens is that the documents that we have are already clustered into, such kind of clusters. So whenever there's a new incoming document, then it is matched to the cluster center, or the, to the clusters, each of the clusters. And the document, if it is closest to any particular cluster, is placed in that respective cluster because it probably belongs to that category only. So this is how the documents are always, organized. So that we can identify which are the, and this can also help us to identify which are the similar documents, so we can treat them similarly. So it can be used for document uh, clustering also. Okay.
Okay. Yeah.
And in the documents can be represented, as I showed you earlier, in form of some binary vectors, where the columns of the document would represent the different topics or the different keywords that it is having. And the similarity can be found out with the help of the cosine similarity that I already told you, and like that, and then they could be clusters. So we'll be discussing that in NLP as we go along. When we talk about documents, then we are going to have a look at some of this stuff also, but you can also think about uh, a very typical use case of clustering that is in case of documents.
One last question here, ma'am. There
Yeah.
could be, like, suppose we have that articles available with us. There are some classification techniques also, and there are some now this K-means clustering or other clustering techniques. What technique we should be taking for document classification? Whether we should go for classification methodologies or we should opt for clustering.
Okay. So first of all, see, there's a basic difference between when to use classification and when to use clustering. You do classification when you know the different categories already in the data. Let's say I've got some 1,000 documents. I already know the categories is going to be news, entertainment, and maybe sports, let's say. If these are three different categories, I already know these categories. Then what I will need to do is build a classification model. And whenever I have a new document, I can find out its class label. But in case of clustering, I don't have any categories given to me in advance. And what I will do is cluster all the points based on the similarity. And after finding out the clusters, then I can have a look at all the points or documents that are falling in one particular cluster and try to study what is common. So when I try to study what is common, probably I'll get common topics out of all those documents. So maybe three clusters are formed, one belonging to news, one to entertainment, one to sports, like that. So the two work in different ways, as I already indicated. Okay.
Yeah, thank you, ma'am. Got it.
Yeah. Any other questions, anyone? So if there are no questions, then we can discuss the formation of the groups. I think a poll was there already. uh, right? And we had shared it right now also. Uh, since not many of you have filled the poll, few of you only have filled the poll in which we tried to decide whether the faculty, whether the groups will be formed by you or we will form the groups. So, as per the few inputs that we received, which are very few, I think just one third of you, not even one third. Yeah, one third of you took that poll and answered. And based on that, it is based on the faculty or us forming the groups. So, first of all, I think I need to give you the group size. So, the group size that you have to take is 7. Okay. So, you should not choose more or less than 7 people in the group. That is one thing. Now, the second thing is about formation of the groups. According to few people who have polled, answered the poll, it needs to be formed by us. Now, formation by faculty, again, how do you want to form the groups? There can be so many ways, like based on the geographical location, based on the area of interest, like, or the area of expertise, or it can be based on what is the coding expertise, or it can be based on the total number of years of experience. So all these are really very subjective and difficult. So my suggestion to all of you is still that you form your, or all of you try to form your own group. Size should be exactly 7. If there is anyone who is not accommodated in a group, then we can discuss trying to accommodate in one of the groups. Does it sound okay to all of you?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes.
Yes, ma'am.
Ma'am, I would defer to
The
this.
problem is,
Yeah,
yeah,
because see, ma'am, I'll tell you, if the class size would have been less, I mean, 30, 40 people, and people would have known all of us. I mean, there would be some intro and people would have known. Forming the groups on it's not a problem. Problem comes when we have 100 plus people here.
Mm.
And obviously, the problems you stated, it's perfectly valid points, geographical things or experience or all those things. But I would still suggest, like, please make the groups on you. If you can make the groups, better we can sustain with those. Otherwise, there will be always a biasness with people. Like, I want this person in my team. Oh, I don't want this person in my team. All those things. So, better to have this.
Yes,
yeah,
Yeah.
Shivam,
I agree to
I
this
agree.
point, ma'am.
Okay,
I
well
would
said.
Yeah.
I would differ.
I
I'll
Because we
tell you
don't
why.
have any data to form
Yeah,
a group. I
yeah.
think you might be having the data on the basis of which you can make a meaningful group.
I'll
Uh,
partially, sir. I'll just add one point. So suppose I'm working with, I mean, day-to-day life, I'm meeting someone regularly, and it is easier for me to sit with him and do a lot of discussions. Then if the group size is 7, probably 1 or 2 or 3 people we can pick by ourselves and rest ma'am can pick. Can it be hybrid? Because see, if I am with somebody and I am very comfortable and we can sit together and discuss a lot of things,
So
then
Ashish, I would suggest in that case you can separately put out a request to ma'am that ma'am, I would want these 2 people in my group. Rest you can assign to us. Then I think that thing should be fine, I guess.
okay.
so,
I'm agree with this because it is very difficult for me also to uh, to how which people to whom I have to collaborate. Okay, because I don't know exactly. So it is very difficult from who are from which background, ground and from which geography locations. It's very difficult from my part.
okay. Suresh, do you want to say anything?
Yes, ma'am. So currently I'm living in US. So the
Mm-hmm.
thing is, it's so hard for me to collaborate with someone from
Mm-hmm.
India teams or from India timing zone. So
Mm-hmm.
what I did for me, I can share you my screen for a minute.
Uh, you can tell
Uh,
if
so
uh,
I have a co-partner here in US, is
mm-hmm.
in the same company. We both are working on it. So
Mm-hmm.
what I did the last week, kind of I connected with him. So I prepared a complete the notes so far how much we have done that, and each and every class I have prepared it, and then I come up with a class session with that, how we can start working on the sessions and all we can do that one. So I've been like kind of been created as a class sessions, and how we can go for the phase one and week one what we need to study, and week two what we need to study, how many phases exactly, what are the notes we go through that, and the sessions which is we come through you and Mithun and other classes. I prepared completely the structure with that one on the weekly basis, and fundamental of mathematics and deep learning. Machine learning, which is the concepts which we prepared it, data preparation. So everything I have cleared. I clearly written that notes so far, and we are following the timetable. Myself and my friend Srihari. So this the way I'm contributing and some practicing some past sample programs, and then Python programs, which is the real-time programs, and writing some models also with respect of on the evening time after office hours. And we both sitting together and going to the record sessions and data preparations. What are the materials we have it, and everything like kind of we are going through that. And phase two, I'm starting like machine learning with unsupervised learning. So we are splitting that on the weekly sessions, myself and him, and we are coming with the things like this. And right now we are working on the model too, right? Today
Okay,
session also.
Suresh, just for sake of time,
Yeah.
you can do a stop share. I saw it's good effort that you are putting in. But what is your suggestion? The person whom you are working with is part of, so you want to team up with him in this group. Is it okay? That's
Yeah,
what you want
that's
to say?
the thing that will be helpful for me because we both are in US, right?
Yeah, so that's okay. But what I assume is he's part of this group only, this course. That's what you want to
Yes,
say?
yes. Yeah,
So
yeah,
you
he's part
can
of
be
this
part,
also.
you both can be part of the same group. So what I will do is that we'll do it hybrid way. That is, that I will initially ask you all to form groups. I will request you to socialize with each other. I understand that there are a lot of participants, and that if you wish, what we can do is from our side, we will not share the addresses, but we can share the broad locations of the participant. Let's say Delhi, how many, who all are there? Let's say Bangalore, who all are there? Like that, we can share. So you all will have some idea about who's near to what location and all that. And then always forming groups on your own may be a better way because you might gel well with certain people, right? And then once you are done, then people who are left out, they can be accommodated, or if there are any special preferences, then that can be accommodated. So my suggestion to you is first try to form groups on your own only. That will always be better than the groups that I will find, because you see that I cannot use a lot of criteria. Either I can use total number of years of experience, or I can use, let's say, the locality and all that stuff. So in that particular case, probably the groups that I may form may not be the best groups. That's my thought on it. And I've observed this over so many batches and so many courses that I've taken, that always the groups that are formed by the learners are always better, because people feel more comfortable with certain set of people. By doing a manual allocation, as I will do, you might group with someone with whom you are not very comfortable. That is the thing. Okay, Subham, what do you want to say?
Sure, ma'am. I agree to what you're saying. Just one suggestion. I mean, obviously, people who have some preference of teaming up with someone can share this to you, and whenever you will be forming the groups, you can take that into consideration. But on an overall, I would suggest like when you will be shuffling the groups, I mean, people to the groups, can you please take care of only geographical location? So it's all better for us as well to go and meet offline and communicate about the course and I mean about the project and all. So just a suggestion.
Okay, so that's why, okay, that I've noted. We can do that, and a better way would be that we can share the broad locations against the names. So you all can also talk to each other and then try to see the interest and form the groups. If people are left out, then I can put on the basis of the location. Anyhow, needless to say that even if I try to club people from Delhi, Delhi is very big. Bangalore again has lot of constraints in terms of physical meetup and all that. But we can try to do that. I can try to do that.
Ma'am, one request in case if you can also include the domain expertise while you're capturing all the details, that will help us to form the balanced group.
Yeah, but that may be a little difficult for me to do. Because there are so many of you, and then which expertise to put in which group, and then probably some group might feel, because not all expertise
Can,
may be available in equal numbers. So that will be a little difficult for me to do. For that only I'm saying that
ma'am,
you can, yeah.
No, let
Ma'am,
him
I
take.
think
But I think this is the
location
one
and
of the key
experience
aspect
would be
of
good.
this is one of the key aspect of forming the group. And what we can do means a poll can be organized because you are better know which domain expertise are required for this course. So, for example, data scientists, you need coding people, you need Python based. So, some of the logical grouping IIT Rudki can suggest, and based on the polling, we are going to poll it, and poll will contain the name and the other resources who are voting for that. So in this way, you will able to have a list of the people who belongs to the same goal, same domain, and then choosing from there some sampling and some classification. We can do that one.
Uh, okay. See, if you wish to have a data on, let's say, who's good at programming or what is the expertise and all that, so probably you can suggest what data you want. We can try to capture it in some way and share it with all of you. And then you can, form, because you see that even if let's say we capture the expertise or the number of years or something like that, but when I the groups, the total number of people with the same expertise may not be equal. Let's say if we are having 7 size groups and we are having some 15 groups or 20 groups, then and it's not necessary that 20 people with the same or 15 people of the same expertise may be available. Therefore, that data we can collect, but it may be difficult for me to utilize it directly to form the groups. I can have some simple criteria like, let's say, geographical location. I can use that and club people together, like that I can do. Or we can provide the location, take the data from all of you, or already the data that is available. We can provide the broad locations. Then you all can talk to each other if you wish and form the groups. That may be easier for us also.
Actually, the
Yes, ma'am.
idea is
We
slightly,
agree to.
for example, if as a group, I need expertise from data science background. So if we
Yeah,
can,
Govind, I think I'll suggest one thing here. I think we do not need any domain expert, or we all are learning here, right? So and the domain doesn't matter. I mean, whatever the project or things we will be taking up, it could be from any domain, right? So the domain
No,
expertise is not required.
domain,
What
the
is
no,
idea is
important?
slightly different.
no,
Shashank,
no,
let's
no.
take an
You are
example.
wrong.
If you come from background X and you are
No.
trying to solve a problem in domain Y, you will not be able to
Mm-hmm.
complete
It
the
is
problem.
data science and the coding related. Domain is not for the
Yes.
textile domain on the or the manufacturing domain. We are not talking for that one.
So let's focus it on data science project kind of thing. Let's forget about the domain. I think the experience, what ma'am said, that years of experience could be a mix in a group, and that geographical location. I think these two parameters will be sufficient for us to make a group. And later
Because
on,
of the
if we need
use of
anything
the
or
data
shuffling
science.
or anything, we can place a request.
I
No,
think
that's again use the criteria to
domain
have a
expertise is
shuffling,
very much,
etc.
domain expertise is very much important here, Susan, because whenever the ma'am
Yes.
giving the project, it belongs to some domains. Okay, it's not a generic domain. So if a person belongs to some particular domain and the assignment is given to that domain, that
But
group
that
will be
is
very
okay,
much
Ajit. I
comfortable.
think
Right? Yeah.
we can do some research on that domain. It is okay. This is a part of our project also, right? Why we need a domain expert earlier only? We can do some R&D and we
Why?
can learn
So
that.
why we require the data scientist? So you can also learn the data science in that case. So
That is what we are
relevancy
doing,
is,
right? We are
Okay,
learning data
yeah,
science and we are
okay,
applying the
hold on.
yeah.
I
concept.
think just 1 second. This will not converge like this. So what I suggest is that I think the way we can do is that I think I can see something like software development, data science, something, something. So skill set, experience level, domain, probably location. What we can do is that we can collect this information from all of you, and of course from people who respond to it, because not all of you do that. And then we can share it with all of you only, like the name of the person, maybe the years of experience, domain, and skill set and location. Maybe these 4 things we can capture and share with you. Then you can utilize this information and then interact with those those whom you feel are you are interested in. Maybe you are interested in certain years of experience, domain and all. You talk to all those people, right? And like that, try to form the groups. And then at the end, I will we'll give you some time to interact and try to form the groups. And then if there are, let's put it like this, that if people are left out, those we'll try to accommodate. And remember, when we try to accommodate, we'll try to match up based on these 4 attributes that we are collecting. But then no group should say, I will not have him, I will not have her, we can't keep him. That things will not be acceptable. Okay? Because I'm giving you the option. We'll have these 4 things, okay? Location, domain, years of experience, skill set and all that. So I'm adding location to it. These 4 points we'll collect. Whosoever responds, that data will be compiled. We will share it to you by the next weekend or before that, as soon as it gets collected. Based on that, you interact with people, form groups of size 7. If whosoever is left, I will try to accommodate based on his or her attributes, and who's in whatever group I will place, that group has to accept. Okay, then that group cannot refuse that we will not have him or her. That won't be correct. Is it okay with everyone, acceptable?
Yes, this is fine with me, ma'am.
Yes, ma'am.
This is
Y-
fine.
You
Yes,
you know
this is
you know
fine.
better what projects, you know much better that what project requires, you know what much better that what skills are required. So please poll a request on those things, and we will respond. Future Sense will collect that data, and they can randomize it
No, we will
accordingly.
share, yeah, after having collected that data, we will share it with all of you, and that you can utilize to form your groups. Okay, and then whosoever has not been, think of it as an opportunity to socialize, network and form the groups, because those who are not accommodated, be put they will be assigned manually by me. Obviously, the amount of you know thought process that you can do yourself into accommodating yourself in a group will be much more than what I can do for 100 plus of you, right? So I'll have to use some criteria and just put it. So that may not be that good as what you can do yourself by meeting up and all that stuff. So we'll share the poll. I'll request Simran, please share these 4 poll containing all these 4 things. They have to, everybody has to enter this. Whosoever enters, it will be compiled and shared with all. You use it to form groups. Think of it that you must try to place yourself in a group. Worst case, you take the worst case as the case where you are not able to place yourself, in which case I will do that.
Yeah,
Okay,
that's fine.
Dinesh. Yeah. Uh, Dinesh, you have a question?
Yes, ma'am. This is not regarding the I mean discussion though, but we haven't been receiving the emails or any communication with the polling. Maybe Simran can answer that. Few of us might not be receiving it. I mean, in my
Receiving
case, I
what?
haven't received
Sorry.
any communication over the polls actually.
No,
So
no,
it will,
the polls, no, the poll, whatever came out has been collected and I show it here. We
no,
don't
no,
see
no.
that becomes endless to have a poll and then distribute the results to everyone. We don't do that. That's why you
No,
are
no.
not receiving.
Sorry, ma'am, not that's not my question. It's like, uh,
Oh,
I haven't even able to poll
the
actually. That's the
oh,
question.
okay, okay. You haven't received the form. Okay,
Yeah. Yes, yes.
okay,
Maybe Simran can answer that if we are getting missed
okay,
out of his message. Yeah,
okay.
I am sending it to you at dineshhalaharvi@gmail.com. That's your
that's,
email ID that we have. I'm sharing
that's
it to you
correct.
over there.
Sure. Thank you.
So just
Uh,
check your email there. I think you should be getting all emails from Futurance on the personal email ID, dineshhalaharvi@gmail.com.
That's correct email. Yeah, I'll double check.
okay. So then, Simran, I'll request you to prepare the poll. Probably we can roll out this poll by tomorrow. And please be on a lookout on your email ID for receiving the information. Please respond to it, and then we'll share it once most of you would have responded. Probably I expect that in 2 to 3 days, everybody should respond so that we can distribute the information, and then we'll go on from there. Is it okay, everyone? Then
Yeah, that's fine.
And
And
just
Simran, one can you can do, you can put the link in our IIT Roorkee the Future Sense website also. If someone miss the your mail, he
yeah,
or she can go. Yep.
I'll put it on the LMS on the announcement as well as share an email.
yeah.
Just to add one thing, ma'am, like someone of us like sent already a Google Sheet. So sometime back, like when the batch started, someone got initiated this one, and I think pretty much similar data is available. And just now, it's there in the chat. Simran, see like if you can get that and continue on that, or else like you can have a new one. Anything is fine.
What is this? This is
There is a Google Sheet, ma'am. Basically, the four parameter which we are looking for, right? It's already there in that sheet, having already hundred of people's details over there.
okay. Okay,
I mean,
then
pretty
I
much
think
similar.
okay, fine, fine. Um, Okay, then thank you all. Thank you very much. Have a great Sunday, and we'll meet up next turn. We'll discuss all the stuff. I think there will be a little change in the schedule that I've shared, very slight change. I think the next turn I might have kept a session on doubt session. So what I'll be doing in the next turn will be a little different. I'll cover some content there. So the doubt session will get shifted by 1 week. So then instead of the coming Saturday, it might go to the next Saturday. I mean, next to next Saturday. Okay. Okay. Thank you all. Bye-bye.
Thank you, ma'am.
Thank you, man.
Thank you, ma'am. Have a great day.
Thank you, man.
And
Bye bye.
bye.